Okay, we start today. Again, the purpose try to share with you how to use simulation and iPhone's approach, cell phone approach to do the traffic management problem. Okay, this one is just use a simulation. If any of you have no background on simulation, I suggest you to study some traffic simulation class. And then the next one I will show you is again use smartphone approach to mitigate traffic congestions. This I-695 is in Baltimore. The one I show you, one is Washington D.C., one Baltimore. These are the two most important metropolitan area. Why is important? Because Homeland Security gave a lot of money to deal with the potential terrorist attack. After 9/11, the government get a lot of money and try to protect those cities. These are the two cities receive a lot of money. One is Washington D.C., one is Baltimore. And this is an incident management program. I told you before, for day-to-day recurrent congestion, if you have done a good traffic management, actually not much you can do in short term, okay? But for non-recurrent congestion, such as incident management, or work zone, or spatial event, that's more likely you can get a better accomplishment of improvement. So this is an incident management module which includes the following features: GIS-based map graphic, input-output. Nowadays, people always use a graphic as input and output. Okay, a knowledge-based incident duration model, prediction, dynamic evolution of traffic queue, estimate travel time, delay, speed, expandable to incorporate advanced freeway control strategy. There's one missing component here: how to convey those information to drivers. Okay, those have to go through cell phone, roadside information system, and web-based information system. Okay, but again, how to efficiently relay all the information to drivers en route or pre-departure could be a research issue too. Some of you may know CORSIM. It's a freeway corridor traffic estimation program, and this is the base plan for Baltimore network. Again, you have a CORSIM in your lab. CORSIM is a public domain from the federal highway. It's cheap and not very flexible, but sufficient for use in freeway applications. The entire system has structure include the following components: graphic and navigation tools, input, output, which is time, location, and blockage. The blockage could be, I mentioned earlier, could be the accident, incident, or work zone. And this knowledge-based module, if you learn the traffic and transportation, used to be very popular called expert system. Means even you don't have models, but a valuable experience based on operators or based on some long time working days, commuters can provide you information. For example, you always know by 7:30 to 8:30 which highway will be congested. That could be knowledge based too, okay? CHART is the one we call Cooperative Highway Action Response Team, okay? That's the name of the or traffic management team. Cooperative Highway Action Response Team. If any statistics can also be used as knowledge base. Knowledge base means you don't use complex math, but use if and then, if and then, if and then. That's kind of simple relations to be your solution or to be your information. And then you need the incident duration estimation. Although it's not easy job, but still can be done to produce information better than nothing, okay? For example, you have a one-car collision, occupy one lane, 2 injury. So in general, based on location, if you have enough data, based on location, how far from interchange, weather condition, traffic volume, you should be able to provide approximate incident duration, means how long it take the response team to clear the incident. That include what? Include the detection time, arrival time, clearance time, and recovery time. Recovery time means you clear the incident, but traffic still takes some time to back to the normal condition. So those all together called incident durations. This can be one of study, okay? If any of you are interested in a computer program, you don't need a statistics model. As I mentioned earlier, you can use a knowledge-based model. For example, you go collect data from a police department or freeway traffic bureau, get all the past data and classify different type of incident with different number of injury, yes or no, any fatality, and weather condition. So you can classify all the possible contributing factors into what? Into a different type of incident. And then you can use a model, you can use a discrete model, or can use continuous model, or the simple way, you can use if and then. Okay, write computer program, say if we can, if at some location, if weather is raining there, if blah, 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 blah. Okay, if nobody die, then what would be the approximate duration? Okay. If you cannot be so sure about how many minutes, you can say that will be between 15 to 20 minutes or 20 to 30 minutes. That can be a research if you have good data. And that can be useful too, okay? So any incident happen, you can display information at the roadside VMS or by radio station to broadcast to all the commuters. And then output is what? So-called the duration is prediction purpose, okay? You know right now have accident. Then you want to know what would be impact once before, once after. Before means accident has not been clear yet. You can inform the driver, say, okay, sorry, I now have accident, and then at this time the queue has been developed to which interchange. You will expect to have a half-hour delay, and current speed maybe only 25 miles per hour. Okay, all the information. So driver know how to make decision, whether they should continue get on the freeway or they should take a alternate route, or maybe they should change their mind to go to take a high-speed rail. Okay, so how can you have this information? You can have statistics model, but most reliably should use a simulation. Create a simulator and simulate, produce the information. Of course, this simulator, the one I show you, have to be well calibrated. Well calibrated means before application, you should make sure your simulation can create and generate the traffic condition identical to actual traffic condition without accident case. Okay, that's called calibration. So this is our system. Okay, this one quite early. I think 6 or 8 years ago, a research product, and this is a 1 year's student master student work. So have 3 purposes: accident, work zone, and monitoring purpose. This one, this 2 has been done, but I didn't include it in the presentation today. The more important purpose is try to provide you traffic impact under the incident condition, okay? This is a program input. So if you guys are interested in working on the traffic operation control area, you should learn more about computers. And GIS and simulation are the two basic tools. So this is GIS applications and create a nice graphic to promote application of your system. Okay, here's instructions and here's navigations. Okay, one, zoom in, zoom out. Of course, you know that's very common. And usually, you got reports say we have accident, but you need a more precise accident location and identify possible impact area and potential detour route. So if necessary, you can implement detour operations. Okay, you can zoom in to see the target point, identify the actual accident-related information. Okay, we found out in I-695, identify the approximate incident location. Okay, then you input the information. Now we, in current system, stay as us, try to improve this part of interface. The reason they say the interface still takes time. Can you have automatic input? It means if the response unit already reached this location, and based on the GPS equipped response unit's devices can automatically create location, input all those information. Okay, it can be done, but sometimes may not be so complete information because GPS vehicle already get to that particular location, feedback information, then you know which lane, which direction, right? But what kind of accident? Still don't know. GPS cannot tell you whether there's one car collision or two car collision, okay? Unless you zoom in, okay? So we are still working on. That is not really a publishable subject. So we are not that interested to get that job done, okay? That's just an enhancement of the current map-based system. But this input is done by whom? By either the control center operator based on information or by the incident response team, whoever get to the location earlier. In Maryland, this system is input by the control center. In Virginia, they are different. They input those information directly by the incident response team's member. Okay, so you identify the locations between which exit, okay? So here you see, even for a simple design, we try to be very clear and easily understandable by the potential users, okay? So inner loop or outer loop, okay? The two different directions. So select your travel directions, load in more detailed network data. Okay, you know the inner loop. Now specify the additional information which could be available from the site operators. Okay, very important to know how far the incident location from the interchange area, from the potential interchange area. This can also be used for non-freeway too, okay? As long as you know the difference between freeway and local arterial, which include the signals and signal timing informations. So you can specify the location. Again, those distance from this distance can be directly input from the, it can be automated from the response vehicles if they have a GPS equipped devices. So we may be not necessary input those information manually, because during the incident condition, if so urgent and some people die, you want to finish those input data as quick as possible. So input the actual locations. Those locations is important. Why? You could dictate where could be a potential exit detour operation or not, and also guide the response team. A response team have several different units. One could just be from the traffic management response unit, and you also include what fire trucks if there's some fire caused by collision. Also have an ambulance. So usually it depends who got there first to report back and continue to provide information to guide the other support team member to get there together. So they need to know where to get on. They should take the same direction or opposing direction to get to the incident locations. Actually, this kind of system you can design for the sense or Sinju Science Park too, okay? It's not enough. You know the location, you also need to know how many lanes get blockage, also which lane. The shoulder lane, close to the shoulder lane, or in the middle lane, the impacts are different, depending on traffic conditions. So you need to know exactly how many lanes, which lane, in order for you to have a reliable estimate, okay? Many times, if the accident happens in the inner lane, it's much easier to deal with, okay? Because it's likely not to block the entry of the ramp or exit the ramp. But if accident happened or blockage occurred in the shoulder lane or rightmost lane, then could be concurrently blocking the shoulder lane too, okay? And then if you do a simulation and do the access control, will be different. Okay, this is the information from database, okay? So estimate incident duration from the historical data. That's why I mentioned to you, if you have nothing, you have data, still can provide information. Okay, here's incident natures from the historical database. I don't know where you can have those data. It's typically the freeway or highway department. Typically, you should have those information from the highway department. Okay, if you want to search for your database, you can search incident nature, for example, 1 lane blockage, 2 lane blockage, or collision, or blah, 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 all kind of condition, okay? At the same location, depend on different nature of the incident. The impact could be different, but all could be useful for your information. So here, example is criteria from the historical database. I search incident nature, or number of lane blockage, okay, 2 lane blockage. What time, yeah, pick out or pick out, you can select from your database. Here I select both segment at current locations, okay? And so from the historical, here from the database, what days, okay? 4/14, that's time interval, the nature was collision, personal injury, okay? And this one only vehicle fire, it's different. You see, those different natures, the duration is quite different. Unfortunately, this information is input by the operator in the historical record. For example, here, collision, personal injury. They didn't tell you how many people got injured. That could be different. See, once, for example, 39 minutes, 120, they both say collision, personal injury. But that certainly have what? Difference on how many people involved in the incident, okay? So a lot of times, the database provided to you may not be sufficient to do a better estimate. And those are independent variable too, okay? So if you try to do this type of study, you can first get database from the highway bureaus and then analyze and suggest them what would be the completed data format and advise them from now on to collect the data and follow this format. And then after 1 year, 2 years, you could have a better database for you to do a research, okay? So the number one issue is how to design a database which can include all the possible factors for you to do a good estimate. If you don't have sufficient information here, your model will be very difficult to be reliable. Okay, so number one study in this area, usually when we start to persuade the highway department, is ask them to develop a database based on your suggestion. And in the meantime, from this historic information, you can show them how useful those information, even with incomplete database, incomplete information. I'll give example. In this accident, from the historical database, we come out average estimation duration 65 minutes. Okay, and then based on the incident time, okay, time of current location incident, and then you can also have one based on your model estimate incident duration, and then you can verify who has a good estimate after accident actually clear, and then compare with the highway department's response team member. If they don't have such information, what would be the estimate? So you can prove how useful your information. Certainly, I hope your model is better than their judgment, okay? If not, then they won't give you a project to do. If you prove historical data and your model estimate are much better than they usually do by their own engineering judgment, then it's one way to convince them to conduct this research. Okay, here I select incident nature, I select collision personal injury, because based on report, it's a collision and personal injury, okay? That's why I come with those. Here's all different classifications. There's different location and different city may have different classification. Those are standard classifications. This category usually will have a much longer incident duration, okay? Okay, so when I narrow down the collision and personal injury, the database much small, okay, and which day. So come with estimate during the peak hour, okay? A peak hour turned out to be shorter. You know why? Why peak hour? Suppose peak hour congestions impacts more, but peak hours, the highway department, in general, they have a rescue team patrol on the freeways. Okay, so peak hour, generally, they have more staff available to do the response job. And off-peak usually have less people in the operation to respond. So usually it takes a long time for them to get there and to call. They maybe get there early. They also have to call the ambulance, call the fire trucks. So it takes much longer. So in this case, we narrow down, happen during the peak hour. Because here we say the time of the current incident was 4:25 is afternoon peak period just beginning, okay? Then we found out this location have a two incident, 133, 121, so average 27 minutes. So you can see even without the model, but if you have a sufficient database, which could give you good estimate, and sometimes that location could have no accident, no previous accident. So what can you do? Well, you search the location with similar geometric features. Use that as information for comparison. So we found the two similar cases here. This estimate with simple math. Okay. Again, I mentioned if you show based on the historical data and come with 27 minutes, which finally found out is close to the actual incident duration, and close in a sense compared to the idea, the estimate by the Highway Bureau without using the historical information. In general, they don't use this information. They use their own judgment and prove historical data is useful. And next step, prove your model is useful, okay? The estimation purpose for real operation, a lot of times, they don't use 27, 26, or 29 minutes because for actual field operation people, 1 minute means nothing to them, okay? So always use a 5 minutes interval. Because for response purpose, quite different for 1 or 2 minutes in the estimated queue. But in terms of the response time and operations, they always try to be more conservative. Okay, now you have all those information, okay? By the way, I-695, locations between exit 13, 12. Is this accident location? Yeah, you make sure yes. If not, have go back to re-input and time of accident. That's very important, okay? Approximate durations, okay? You want to change or not? If not, continue. And here's the location of incident. And here's summaries of all information related to this incident. And this incident information, although now it's ongoing for estimated impact, but this information again will be what? Saved in the database, become a useful data point for next estimation purpose, okay? So next time in the new data point, you will have one more cases with all those informations. Your original database may not have those information, but again, day-to-day operations, you collect more data, collect more incident information, then you can use the way to enrich your incident information database. Okay, now we have all those information, okay? Starting time, estimate incident duration, 30 minutes. Block locations, which lanes. Okay, so altogether, sufficient for you to estimate the potential queue length, which is during the simulation. You can use a simple statistic, but may not be that reliable, okay? So here take about 14 seconds to run the operations. Okay, this is operation input, output for the system. You know the delay, average speed, queue length, travel time, these action locations. So you can select which location and also any impact on the detour route. Here show you the distribution of average speed on each segment. Okay. This output is not as good as I like because the number is so close, not easy to see. But you can select partial information to see your input. You can use the line chart or bar chart to displays the possible information. You can use viewed animation too, okay? You can see the delay and report. This information usually is operated by a control center and allow the operator to broadcast those information to the drivers already in the network. Okay, here you can see the distributed speed is okay up to that accident location, and this area start to have a reduced travel speed at those locations, right? Different exit. Okay, we don't provide the precise information on the each location, but we use the between exit as the coverage point. Here show the displays average speed over segment. You can select different segment and zoom into, for example, here you can set up a segment. Which segment you want to see information? Here exit 16, okay? And between exit 18, that's information you want to show. You can also show delay by different presentations. Here's simulation queue length. As you can see, somehow the accident incident caused the queue at this location, and evolution over time, okay? At this original queue, because incident related queue, somehow at the exit also have a queue too, okay? So this graphic information provided good prediction of the traffic condition. I can, based on those predicted condition, if you have a roadside camera, you can also compare roadside camera information to verify the evolution of the queue on the computer compared with actually on the camera you can see, okay? You can define how you define the congestion, okay? 25 to 45 or you can change your definition of congestion by the different colors. In the meantime, very important, if some drivers have not get on freeway yet, you want to provide information, the travel time versus departure time information, so they know by taking different departure time what would be a travel time. And travel time is from where to where, okay, from where to where travel time, okay. So because a network has so much information, you cannot display all the information together in one time period. So you have to choose where to display and broadcast sequentially different pieces of information to different potential target audience. For example, here's roadway segment between these two exits and time period between those two time periods, and come with your estimate information travel time, okay? And this is a simple simulation result. Okay, the above show you the simple application for using your computer skill to design the incident impact information system. And this research involved the two main components, one database, how to use database to integrate with the simulation. The other is try to use to design what would be an ideal database for the incident management. That you can be part of your study, because when we are doing the research, always encounter problem. There's no data, not enough data. So you have to think about, from your modeling point of view, from your prediction point of view, what data would be, and then you can set a database for the responsible highway agency to do your operations. And then you can design the simulation and the prediction model. The one I show you is by simulation, because it's a highway network, it's a beltway with all the route. But if you only have one local artery or one freeway, you may not use simulation. You can just use a statistical model to predict Q. The problem is if you are not using the simulation, then one model can only have one output. For example, you can have a Q model predict a Q, but you only need one model for Q. Then you need another model to predict what? Speed. You need another model to predict what? Travel time, okay? And the advantage of a simulation, if properly calibrated, can answer all your questions together. But to calibrate simulation, it's very time consuming. I need a knowledge and experience, okay? Okay, the second one is, again, the system ongoing. I work with my former student, Dr. Ye Liu. This is also the ongoing new idea. As I mentioned earlier, most of you enjoy playing around with your iPhone. You can see no matter where you go. And the subway, you see everybody do nothing, just look at iPhone, okay, or iPad. Everywhere, people are so concentrated, watching something from the iPad or iPhones. If you can convert those information into useful traffic management, or even for some OD estimation, I believe that will be low-cost, efficient information sources. So this is actually an opportunity for you guys. Think about it. You spend so much time with your iPhone. Can you convert iPhone information to be useful for research application, or even the business point of view? I guess you guys know the YouTuber, right? The YouTuber is one guy from Taiwan, the founders, and he's a billionaire now. And the original idea of the YouTuber coming from what? Coming from the classmate, the good friend, try to share the video with each others. That's the only purpose. They found out you have 10 together want to share the video. It's so much trouble to pass the video around, right? So they come up with the idea with the station, web station, and share the video. And that's starting point. Now everyone's billionaire. One from, I believe from Taiwan, I forgot which university. So you can think about your iPhone, if you can use the information for any purpose. Of course, I'm only tell you how to use iPhone for transportation, okay? You can think about iPhone for other than transportation information. And that could be make you a fortune too. And be sure to donate some money back to a Charlton University, okay? So if you're making more money, okay? So that's the background. Because nowadays, if you keep telling students, oh, go to roadside to collect data, they get bored and not interested. So how about find some idea, can use iPhone information to collect traffic information on the freeways near the Charlton University. See whether that can be a potential project to sponsor your research or not. And iPhone technology is also quite impressively and quite mature too, okay? iPhone here refer to all those similar devices, include iPad or whatever related smart communication and visual technology. A promising benefit to transportation, okay? So that's why it's very popular use iPhone to link with some of the traditional, conventional traffic sensor together to become a complete information basis. Of course, in iPhone's application, you need to have some way to identify those phones is in the building or on the highway or in the shopping mall, okay? So that are different, okay? I briefly review. You can see those are the applications, navigators, okay? Smartphone apps, website with GPS fleet. So iPhone related application or GPS application, to some extent iPhone have GPS, right? So you can say it's GPS application, but GPS is just only location. iPhone can have a two-way communication in and out, okay? And there are many state applications start to use such information, mostly from the commercial, because young guys always try to find the opportunity to start their business. I don't know if Taiwan have this kind of application or not, but should have the potential. For example, if you can say, instead of the Hsinchu city put a detector everywhere to collect data, you can have a company provide those information for Hsinchu based on iPhone information. Of course, you need to filter the information, identify by segment, by roadway, by time period. It could be a business selling the data point to whom? To the Google navigation system in Taiwan, selling the information to the traffic bureau. Depending on how you do a marketing, it could be a potential profitable business, okay? But whether profitable or not, it depends on how good your data can be used by the potential user and how quickly your data will be copied by others too, okay? If data and technology is so easy to be copied by others, you may just donate, okay? Academia in the university, we retrieve this real-time traffic conditions, speed, density, volume. That's what we use. Remember, every city, when they talk about ITS, the step one, they try to do is what? To install detectors, install sensors, okay? More generally, we call sensors, cover the detector and video image sensors or camera too. And that step one takes a lot of money. All they can get is speed, density, volumes, okay? You properly use the cell phone information, you can also get density too. You can have volume too, okay? You can have speed too. Of course, not directly. You need to have some way to clean the data and from the data to do estimation, okay? And provide traffic information, public transport scheduling service to all the estimation and travel behavior. All the information is so important for all the applications. You can see, based on cell phone, you actually know this guy directly come from home to office or not, or go to 7-Eleven to eat those garbage food and before come to the office or not. So you can do so-called activity-based analysis. Remember, if you do a travel behavior study or doing urban planning, there's one area called activity-based study. And all cell phone information can track you and provide you all the information instead of doing a survey, okay? So the idea is traffic people, traffic bureau should think about, traffic researcher should think about how to take advantage of information already available rather than spend a lot of money to do your hardware purchase and even more money to do your maintenance purpose. You can think about if everyone cooperate with you, provide you you don't need everyone, it's large percentage of people provide you the information from sampling point of view, can say sufficient samples available for you through the iPhone information, then you don't need to put the detectors and you don't need to put so much resource for maintenance purpose for your systems. Of course, you need to have what? Technique to aggregate, disseminate, and actually filtering the information to different customized purpose, okay? Here we talk about how to use this information for our traditional traffic management purpose. So building up a comprehensive database for planning, traffic management, and academic research in a much lower cost. Here you can see this next graphic show you all the potential applications. I try to present this project everywhere, just try to advise you. You could become a big millionaire if you have good idea, and every day when you look at your iPhone, just concurrently think about how can that information be useful to make fortune for you, also to help government reduce operational cost. Here's application. Works on asset management, okay? Mobile sensors, government agency, and here the potential applications: incident tracking, management strategy, ranking of the possible plan, incident duration estimation, broadcasting information. Through what? Through the signal control, through the VMS information. You can also, iPhone give you information, you can also feedback information to iPhone users. So you can use active way. For example, if some emergency, then I don't know Taiwan, in US, they automatically will inform everybody within that control boundary. Everyone move in that control boundary, your iPhone will receive the emergency information, alert you the emergency, okay? So that's active way to inform you. We could use the same idea if accident happened. We know the accident impact area could be 3 miles. Then all the car entering the 3 mile or maybe 3.5 mile, give a margin. You inform them actively this accident, what would be the cue, think about whether you should do detour or not. Or you can give advice to detour or just give them information for them to make their own decisions. And those are related benefits, okay? Here's the database, information database, and condition database. The rich information, if properly organized, can be valuable resources. These are the applications. I chart, the one I mentioned to you, chart the Cooperative Highway Action Response Team. I stand for the Intelligent Applications. And this University and Response Operation Team. This is a house in the control center. This is a roadside response team. In the peak hour or peak hour, you always have a response unit travel or patrol around the highways, and this information to drivers. This may not be include driver. English should be trip makers. Some could be stay at home. Driver generally refer to those already in route. These are the management informations, okay? We can do a lot of travel behavior. Is most useful information and OD study, okay, advanced traffic management. Remember, traffic behavior usually we do what? Do by survey. Survey usually is not that reliable, okay? So if you can have a so-called cell phone-based activity survey, we have done the study in Maryland. We passed 250 iPhone, at that time the iPhone 4S, okay, to the volunteer drivers. So if we advertise, if you join our survey, we'll pay you how much money. You could also have an iPhone 4S. That time was very good design. I only have iPhone 4 at that time. And so you have the iPhone and you turn on the iPhone for 1 month and allow our center to track your day-to-day activity. That's become a very useful database. You can see where are those guys, and if they have route choice, whether they select a freeway or local arterial, which route they select. And then you can come back, track, and if you can estimate directly from model reliability ticket. If not, you can come back and ask them why that day you do not choose close route instead of taking the longer route. And sometimes you prefer not to ask them because then you bother them. But based on their stop location, you can see, oh, they stop in the shopping mall, or they stop at school. So you know they maybe drop the kids to the school, okay? So that's provide activity-based time series and spatial information for travel behavior study. So it's very useful, okay? Of course, very expensive. Give everybody iPhone, okay? Now you don't need it. Now everybody has iPhone. You just say, okay, complete 1 day. I will give you how much money, okay? Maybe they're willing to join together with you, okay? So part 1, please, we'll get part 1 and take a break. We're in Washington, D.C. There's a coverage by our main area. Here's entire Washington, D.C. And our university is, where is our university? It's inside Beltway area, okay? So in a way, your information will function like you fly on the sky and to view the entire control boundary. It shows the locations, okay? Where the location, we cover the I-270. Here's I-270, okay? I-270. Here's I-495. This is on the Maryland side, this is Virginia side, and the inside this area is Washington, D.C., okay? This one inside Washington, D.C. This is Potomac River. And how many layers in your network, roadway network? You have traffic, you have a surveillance system, okay, and event. There's 4 layers in our original designs. And you have management tools and database management tools. So this, you see, this could be multiple dissertation and master thesis together to combine as an operational website. This operator input. This is the bridge between the, here is the Maryland and Virginia, okay? This is a major bridge, Woodrow Wilson Bridge, connect between the two, and this typically is what? It's a bottleneck. It's a bottleneck always, and every day, no exception, every day have an incident or accident in those merging area. This I-270, okay? Here just simply to show you need a sufficiently detailed map information, geometric information, allow you to have a better location information. As saying here, have a layer to access various types of traffic infrastructure and devices, okay? I-270's area is split into a 2 segment, okay? So that we call spurn area. You want to know you have GIS database, you have a iPhone database, and you always link the database with actual traffic condition if available, okay? So it's almost like a multi-dimensional detection systems. Okay, you can see if your iPhone with all the information, I can, based on the iPhone information I collect, convert into the visual-based traffic information, okay? This information is based on the iPhone information, convert into the traffic information. It's not actually from the camera, okay? Okay, so you based on, again, this, somehow you need to know what the sample size you receive from the iPhone's driver, okay? So based on sample size and based on speed density information, you still need somehow a model to estimate traffic speed, traffic information from your sample data to the actual traffic condition. And certainly you have to verify your model. Of course, if you have a large volume of the iPhone data, then you don't need it, okay? But in reality, some people have iPhone data for you. Some people don't give you iPhone data, but we could have what? Based on the, I will present that PowerPoint, that project maybe tomorrow, based on the Bluetooth information. So you have a volunteer provide you data, you have a passive detectable data. So combined together, still could give you a good picture of information, okay? You can never have 100% data from one source. So here you can see the display of traffic information based on your information, which could be a source information or multi-source information. I'm not kidding now, because you look at just Freeway Bureau, every year they spend huge amount of money to do what? Detector management, detector maintenance cost, okay? Instead of using that, Taipei City, how many people use iPhone? There's so many people who use iPhone, right? And this partial information could be sufficient to function as a more efficient detector basis. Certainly, you have to let the iPhone user have some kind of benefit. Then they may be more willing to work with you. Let them know if they join your club, and every day you will tell them when will be the best route or best transportation mode. For example, I may be my home may be in suburban of Taipei, and I join your club, give you access to my iPhone, and function as a mobile sensor. Every day you will promise to inform me when should I start my trip every day. Maybe you advise them, okay, today you should leave your home around 7:30 and take which route and turn at which location. Then you can get to your destination earlier. Or today, don't take your own car because everywhere congestion. You better take a bus and take a subway together. If you give them those devices and help them provide estimates, say by doing so, when you can get to the office, that could be useful information, relieve your concern, and they may be willing to join you, maybe willing to pay you $10 per month. Could be, you know. I'm not kidding. That could be relieve a lot of your concern. Of course, information has to be reliable, okay? Or you can use the information as a carpool too, right? Use mobile phone information for you. In the meantime, if they have a request, yeah, I want to do a carpool today. Okay, your iPhone can feedback, say, okay, carpool who and who in which location, and there's a nice Mercedes car looking for a carpool, okay? And you can match them. So with those kind of service, more and more drivers may follow you. I believe that could have market, okay? I don't know about Hsinchu, okay? Hsinchu could be, based on your professional information, so many people come to work for the science park, okay? And most of the drivers may be commuter coming from Zhubei, those locations. So you have the system, you can help them match the carpool together. It could be a useful information to minimize traffic demand and provide a better information to smooth, to mitigate the traffic congestion. So think about the potential application, okay? Dumb engineers always work for somebody. Smart engineer become a boss for a big company, okay? Think about, okay? Here's another application. You see the traffic condition speed the information, okay? And the advantage is this kind of system, when you try to develop, usually it's minimum cost. All you need is what? Computer, GIS database. That's it. Your smart, intelligent brain work together, okay? It's not that difficult. But also you need a promotion. You need to have some way, some message to persuade people to follow you. You can start from the campus, start with your classmate, see if they want to work with you or not, okay? I believe that's not only can be a dissertation research, it can also be some kind of potential business. And certainly you can also link with camera or detector information with multi-source information combined together to provide more reliable information too, okay? You can see the VMS, location display VMS. So where the VMS information are displayed together, okay? The idea here is replace or partially replace detector information with your cell phone information. And with that in mind, you can link with whatever existing devices, okay? You can actually develop this system without the permission from the Highway Bureau because you have nothing to do with them. You can do your own job, okay? You can track the detectors. Ideally, you need a similar location with the detectors, okay? And so that's involve another research. If you only have a limited resource from the highway agency, then you want to advise them, okay, now I have 50% of people use iPhone as a mobile sensors. Now you only need to put your money at several locations. That will be sufficient. So you can save a lot of money. You cannot get rid of all the sensors. But for example, on the Sunday, maybe most people still sleep, or most people are watching the football game. They don't wake up. Then you may lose a lot of information too, right? But we still need traffic information. So you may need some of the sensor too. But sensor can only, you can deploy at some particular critical location. So the study will be, where are the critical locations for me to deploy sensors? Or given the limited given the limited sensors available to you, where would be the best location? This is the live information from the sensor or video cameras. So you can see you have detector layer, that's from the traffic bureau, and this from your information. This you don't need to give to the traffic bureau. You can share the information, charge the cost they should pay. So you can combine two-layer information to display the traffic condition, okay? So you can see this one for different location of speed. But the challenge is mobile sensor may not be all consistent from A to B. Same as ETC information, from A to B, some people walk fast, some cars slow, or some cars fast, or some information they may stop somewhere. So you need to have some classification tool or some cluster technique to cluster information into different groups so you can better use information. May not be able to directly apply because the data could have high variance given the mean, okay? Again, you can see all kind of information and you can navigate the system to see where you want to see, okay? And this purpose, you can use a left traffic camera to verify your iPhone information, okay? So you don't need too many of those cameras, but you need to have some critical location to verify your model because you're providing real-time information. And any prediction model needs some kind of feedback to adjust your model, your prediction. You can check signal information too. And those information, if you are the iPhone user, join your club, you can provide to them. For example, if I want to choose route A, route B, I may not know which route has more intersection, or which route may have a bottleneck locations. For example, I want to go from Chao University campus back to my hotel. I have a 2 routes. I don't know which route is longer, which route is shorter. And longer one may have more signals. Shorter one may have more signals, okay? And shorter one maybe have a bottleneck too. Well, one particular intersection could have a more traffic, more congestion. I don't have those information, but if I join your club, by giving you my location, you return the favor to let me know, hey, I say a route choice and choose route A, you pop out information. Route A, you have a 5 intersection. Intersection 2, usually have long delay. I give this information, I may choose another longer route, but shorter travel time. So there's a lot of benefit if you can make your system much more resourceful. I do think there's business, okay? Don't be greedy, charge them too much money. Just charge them maybe $10 or say every inquiry for 10 cents with another 2 inquiry for free, okay? Buy one, get one free. You work with my system for 10 times, and for this month will all be free. You can ask as many questions as you want. You could create your business model. I'm not kidding, think about it, okay? Because day to day, you got not yet. As a student, you can come early, come late, you can sleep late. Not pressure to you. If you work in the metropolitan area, every day, day-to-day commuting, it's a tremendous pressure, okay? How to commute through the all possible transportation mode with the minimum cost and reliable time, it's a big burden, okay? Student is no burden. You can sleep as late as you want. You can also open the event layer, okay? Again, this information is from control center point of view. If you want to provide to the cell phone user, iPhone user, a smartphone user, I don't say iPhone, okay? Smartphone user, you may want what? Narrow interface. Use active way or passive way. Even you can use a voice way if you are advanced. Voice way for communication. This is basically for control center. That's why you need a huge coverage of the information. iPhone, smartphone may not be able to receive all the information concurrently, okay? And you also, most importantly, you want to know any special event or not. By taking the freeway or local arterial, a freeway may encounter some accident or special event. And those information, preferably active, informed drivers in the active mode. It means every morning you get your iPhone, get in your car, you just activate, say, okay, turn on your iPhone communication with my system. Then with number 1 will tell you, hey, don't take route 1. There's accident. That would be very useful information, okay? Or from student will take you, okay, you wake up this morning and turn on your iPhone, you decide whether I should sleep longer or not. And the iPhone will tell you, no, you have an exam today. Go to class early, okay? That could be useful information too, okay? So think about the potential application with smartphone. There are a lot of business opportunity which make you fortune or could be useful to the actual application. Okay, then you can start have the location information. Again, there's 2 ways. One from control center point of view, based on detect information, you receive all the information and construct information, put back to your system. Again, based on information, you construct and input to information, you can send to the potential users. So you have a small database, you can serve maybe small group of people. If you have a large database, your large group of people can apply. We are trying to proceed the information, but my headache is that's definitely going to become a business model. I really don't have energy to operate, okay? And try to let my student operate the systems. And he still needs a lot of models, small models or big models to provide more reliable, efficient communications. And most importantly, is service to who? To your smartphone user. Because you can see this type of system, successful or not, depend on who? Depend on how many people work with you, how openly they want to work with you. Because now we sometimes overemphasize privacy issue. We're privacy issue, we don't want to know. Okay, so may it intimidate or discourage some people to join with you. But you can have somehow ensure they can turn off anytime, will not bother them. But frankly speaking, if your system is good, even the turn off, it still can track. Yeah. I believe you know that, right? Google always tell you, do you allow me to use the information? Yes or no? You say no. Okay, thank you. They turn off. Actually, you say no, they still follow you. You say no, they just know you don't want to use the information. So they don't let you know they are using your information, okay? They still use your information, okay? They still track you. Because cell phone turn off, still have a GPS location, still can track you. And visualize all the instant informations. You can actually pass the image to your iPhone user, right? Because you tell them, oh, there's a minor accident. From the user point of view, you may say, okay, should I change my route based on your so-called minor incident? But they can click on, see the actual image, then they may change their mind. Oh, that could be a problem, okay? If you don't have an instant duration model to tell them how long the incident will be, they can show them an instant scene, instant information, and they, based on their information, they decide whether they change their direction, change their route or not, okay? So you can have a primitive system and continue to enhance your system to be a much more mature, much more diversified systems. If I am 10 years younger, I would definitely work with my student to start this business. I want to retire soon, so I'm not interested to spend too much energy here. But I encourage you guys can start with small pieces of this function together. Or some student, you can have everyone work on different functions. Start with Xinchu, provide the information to the science park's staff or engineers, see whether they can make the system actually work or not. You can also view the work zone information. The difference between work zone and the incident is what? Incident just maybe half hour or 2 hours will be over. Work zone is usually many hours or multiple days, okay? So one's a short-term event, one's long-term event. I'll quickly finish this part 2, okay? We'll take break early, okay? Here show you how to apply the system for the incident management purpose, okay? Remember, mobile sensor can report information actively or passively, okay? Same as ETC, if the car connected to your system get to some location, even they don't call you back, report accident. If you know the guy is on freeway and not moving, must be something happen, okay? So even passively, you can still use information to be your incident detection function. I think I mentioned in the last lectures with the ETC information. How can you use ETC information for traffic management? Did I mention this? I think I mentioned this one, right? ETC, the government only collect money, that's all. I don't think you have any benefit except pay the money. But concurrently, they should give you a lot of information. You can think about what can be done, include instant detection, include the travel time information system, include the vehicle classification, okay? So a lot of potential information, if you don't want to use, will be just for single purpose. So instant can be reported by several mobile sensors passively or actively. Passively is you see the slow speed stagnate, travel time, and you automatically detect that could be an incident. Sometimes they forgot to report you back, and they can also report you back. Now most of this, in our case, 80 to 85% of accident incident are reported by the mobile phone sensor. I don't know about Taiwan. Usually, in our area, if you report the incident information, this phone is free. Okay, you don't need to pay the cost. Passively, just based on the speed detected by each information from the mobile sensor, you can know what their location is, whether they are a potential condition which could be accident incident. If you found an accident, then you can zoom in tracking the individuals to see what the accident information and how the evolution of the accident. This is one way of cell phone. The one I'm going to present, I may want to move tomorrow. Today is use a Bluetooth. You know your PC have a Bluetooth, your car have a Bluetooth, right? Bluetooth also provide the information, unless you turn off. But we can use Bluetooth information as a way to detect each vehicle's movement and speed too, and track the information about incident and do your measurement. Okay, so we can show the report incident, accident or congestion. Okay, some of the recurrent congestion may look like incident at those locations. Okay, it's more detailed information. Some location you can zoom in to see the picture. Some you may not have the access to that locations. You can also report those information back to the Highway Control Center. Based on your information, let them know, hey, where some location could potentially have accident. You may want to use your remote camera to zoom in to find out what's going on and take actions. So this can be a private operate information center rather than government too, okay? Okay, you can zoom in if the from traffic control center point of view. Again, the information I present here is from the government point of view, okay? From traffic control center, assuming traffic control center have the function to use mobile sensor information and also combine with their existing traditional devices such as camera and detectors. If you are running as a private, personal, private system, you may not have access to the camera information, okay? They usually don't allow you to access. But you know, if you can communicate with the mobile sensor, for example, if you are running as a private center, you got the information from the mobile sensor, mobile phone user tell you there's accident. And you can ask them, send a picture back to you, right? Everyone mobile sensor can take a picture, send it back to you, you can report to everybody. So you can still, as a private citizen group, more and more in the developed country, they can do your own operation without government. The government usually know how to consume money, not know how to effectively serve the general population, okay? So you have to push government. With a system, mobile sensor, and the camera and the operator can identify the exact incident location and the nature of the incident. And then you can do an incident management, similar to the one I mentioned in the last presentation, I-695. But the I-695 is an older project, okay? And this with the more new advanced functions. These are information from multi-sources, okay? But I mentioned earlier, because the penetration rate for cell phone almost 100%. You can see now every car on the freeway I tell you, definitely have someone have a sensor, mobile phone, right? I don't see anybody without mobile phone. If you're driving a car on the freeway or highway, you could have more than one mobile phone in one car too. Okay, so the information penetration rate is so high, you can actually use that information alone, without the detector, without the camera. Okay, if those mobile phone sensors willing to work with you, this basically to allow you to track the incident. Remember, even you are running at the traffic control center, you may not have a camera to cover the entire highway network. Some location, you still don't have information about the actual picture of traffic condition. You still have to, if possible, you can rely on the cell phone user to provide you the picture. Remember, in Taiwan, you have a police station. You always call a police station and report incident, right? So why not become more advanced? Instead of call police station, I send you the incident picture and location. Police station, instead of giving you a radio station, they can use an iPhone station to send back instant message, instant information to all the iPhone users. It's more convincing and more strong impact to you. Otherwise, listen to radio, don't pay attention, it's over, and may not know exact location. So that's part, in other words, the radio station for instant information can actually replace by more advanced image and cell phone based instant operation systems. But sometimes people are just lazy, okay? I strongly believe some days, maybe in the next 5 to 10 years, we will get rid of all those sensors. Because those sensors, first, just at one point location. Second, the information takes so much information to keep in your database. Third, you still need a model to do estimation. And fourth, you need so much cost to do a maintenance, okay? They may not accurate anymore, but you still need a maintenance cost. The reason I mentioned that in my ocean city, we have 43 sensors, and some need to be replaced. We are debating whether we should replace or not. We're talking about trying to see any drop some sensors, use the mobile sensor information as a supplemental information. I'm sure if I don't retire in the next 5 years, 10 years, this would be a major research team, mainstream of the research for the traffic monitoring, traffic detection. We don't need to continue with so much information in the air, in everywhere. Why do we still need to rely on the stationary information? It makes no sense, okay? Cell phone is not just for a small group of people, it's for almost everybody. So you guys don't stay on the conventional traffic engineering approach. Just thinking about applied advanced information, cheap, low cost to be useful. Here's some information. Remember my older case is use the database and simulation. Now you don't need it. You don't even need the simulation, okay? Because you concurrently, think about concurrently with your system, you receive, if this freeway, I concurrently receive the actual cell phone user's location speed information from the entire network. So you have a concurrently the information from all the location. So without prediction, you can see the current traffic condition. Of course, you could have multiple accidents concurrently on the highway network. That's very common in the congested corridors. Then you can track each one and provide information. And remember, you will respond to incident. In the meantime, you also collect information. Feedback to your database to enrich your database, okay? Don't just respond information, forgot to collect information. This just tell you if you want to do a prediction, you don't have time to do a prediction. I found a similar scenario from the database or knowledge base to estimate the traffic condition and the feedback to the drivers. For example, they report, yeah, I see the accident in the freeway, 2-car collision, one person appeared to die. How long was that incident going to be? you want to provide those information to help your customers. As a private operation center, you don't have a model, then you can go to search the database. Yeah, okay, similar accident yesterday at another freeway. It take how long? Okay, provide those information back to the users. So you provide good service. This could be a good club. In the United States, we call it AAA club. Just people join the AAA. You can tow truck, help service. You can also ask for information. I think we can have a mobile phone traffic club, okay, service to everybody. That can also extend to include what? Include the trip advices. For example, you want to travel from Hsinchu to Taichung, they can give you advices. You can even link with the tourist information. Okay, they want to go to Taichung for find a good restaurant without the poison food. Okay, you can give you information. So it depends how good your marketing brand. Okay, can be a multi-functions information. So you can link with the business school major student. You can work with somewhere to find a modern traffic information application. Then you could attract more customers to your club. In the beginning, you may try just as club. Everybody mutually help each other. Maybe all those can be your company's stockholder, okay, future for your business. They just quite not moving, okay. Search the related information. See, they're similar to the one I presented before, okay, with all the historical database. Then you can have two different type of information. One from the collection of the information through the highway agency. The other is when you start running your club, you can accumulate those information in your database, okay? And those are not difficult. You don't need a big computer. Now computer is so cheap. As long as you know how to do a communication, how to write a computer program, those easily established as a database. Certainly after you have millions of club members, you need a big computer, okay? Think about Facebook. They also start with a small company. Once you have a more club user, you can extend it to more efficient system. But technology-wise, it's not a big deal. A big deal is idea. How to manage idea to attract more people to join your adventure. Okay, this is a way to estimate incident duration. That's why I mentioned to you, for incident management, the two major issues can be operation issue, can also be a research. One is how could I predict incident duration reliably? This is very, very useful piece of information, okay? Whenever you have accident, you can tell you how long. That's very important. Unfortunately, this model could be location by location. One model for Taipei region could be different from the Taichung region, okay? You always need this model. Second is response operation. How quickly you can respond. How to develop a standard operation process. Why? Because if you do not have a standard response process, people respond unit get to an incident location. Maybe two police, I talk to the two guys cause accident. By talking to them, they argue together, it will take 5 minutes. Remember, when you have accident, they don't care how long people queue, okay? They keep arguing each others. Or ambulance come, usually they can block one lane is enough, but for their convenience, they block 2 lanes. They don't care block 1 lane or 2 lanes, the potential impact to the traffic queue. With those people together, I tell you, your queue could create unnecessarily 2 times, 3 times longer. That's all experience. That's why in our charter system, we actually traffic control center have a joint office with police. Police have a commander in the control center, and they work with us. Why? Because police, they don't listen to traffic engineer. So we need a police commander sitting together with the control center operator, so they can ask the police listen to traffic engineer, response unit team in terms of where to put the police car, how to block the lane in order to have a minimized impact on traffic condition. So we found us at least reduce 50% of the queue and duration. And also they know from the detection time, report time, we start what? Record information, how quickly you clear incident. And that information, either incident report back to the control center, report back to the governor office as a performance evaluation. So they know usually get there. They don't listen to your garbage, okay? If they think there's no big deal, no injury or fatality, of course, they have to more serious, take picture with the standard procedure. If not, they quickly move your car and put on roadside and then quickly give you a report from both company insurance information. If you can go, as you go. If you cannot go, they tow you away, okay? They don't let you stand there argue each other. And that saves a lot of time. Otherwise, police go there, ask you some question, and you respond with dumb questions, and all together 10 minutes, 20 minutes. And you know how long the queue will be? You do the estimation. 20 minutes, long queue, and 20 minutes delay, you need a times 4 to recover. So you need 18 minutes. If traffic reach capacity, you need a 4 times longer time to recover, okay? So that's the way, very useful for incident response operation. Those are two key areas, continue to be a research topic. TRB every year have a paper published in this area. My students have a 4 paper every year, publish one until this year. I told them no more. You found a way easy to publish paper. I said, okay, stop this direction. We move to next directions. I believe we have some problem in Taiwan too. Estimator can based on the information. For example, on the snowing day, you don't have a database from the snowing day. You have to do your own adjustment based on the snow condition. But actually, on the snowing day, incident duration tends to be shorter in our database. The reason is what? In snowing day, they already have so many tow trucks stand by to wait for the removal of the snow. So usually incident duration is shorter. So here, for example, we found the expected duration would be 45 minutes, okay? So anyway, this estimation model can be location by location and based on your available information. And the important part is what? Incident impact area. The one I showed in the previous case used a simulation, okay? Impact area. So you can have one predict impact area, one's evolution of impact area. Evolution impact area means they on the real time condition, how the evolution quickly increase over time. You want the drivers to know the impact area before they are trapped in the impact area. So you need those two pieces of information concurrently show to the drivers. Sometimes you tell them, don't come to a freeway. They still want to come because they don't believe they will be affected, okay? But if you can show them the evolution of the incident and congestion and the impact area, and they will be convinced not to create a more queue and join the congested traffic conditions. Here show you the information, number, lane branch, location, time of current incident, okay? You can estimate impact area. How do you estimate? There are many different approaches, okay? Here is the researcher can provide. I mentioned your simulation, you can use all traffic flow models, okay? Different way. So again, I'm not asking you just play around with the computers, play with data. Computer and data is the way to get information and output information. But still, there's room for traffic engineer to have your model provide a better, responsible, reliable, quick information. General impact. This is very important because in the research you talk about detour operation, divert traffic. How could you know? How could you know when start to have detour operation, when to terminate the active detour operation? You have to base on the dynamic evolution of the traffic impact area. And this certainly research, how to predict impact area, how to estimate impact area, especially impact area evolution. In general, right now, the mathematical model only predict what would be the maximum impact area by the end of the incident duration. But that is not enough. You want to know when they reach the maximum Q condition. Reach the maximum Q, then they will what? They will start to diminish the Q impact. So the evolution of the impact is much more critical information that require to have a more advanced models. I didn't show you all the models. The models in my previous lecture class and my last class, hopefully in the next March. This impact area. Again, the impact area have a real-time information, have a predict information. If you have a good system, try to compare your model. You can always show your predict impact area over time and actual impact area over time. And can check how good your model, okay? Of course, if not good, don't show to the user, okay? Keep for yourself. You can manually adjust impact area. In a way, I can show you, you want to design a system, you got to be what? Very careful. This is actually designed by my student, okay? 3 students work together. You need to be very thoroughly careful, very considerate, see what would be the request or the need of the potential users. Then your system can be useful. I mention again, theoretically, your model may not be perfect. That's fine. We'll never be perfect. If perfect, what happened? If I can do a perfect research or my generation do a perfect research, you don't have a research to do, okay? So nothing is perfect. But it has to be what? Useful and making progress, improve, okay? The traffic condition always change over time, over year. Information availability always change over time, over year. You always can have a new model, new approaches, but have to be useful. The system should be easily operated by your potential users. Otherwise, nobody going to use, okay? Nowadays, people are busy and lazy. And get impact area, then you can decide what would be a management tool. Basically, you have information, speed guidance, detour route, speed control, signal control, on-ramp control, off-ramp control. Okay? That's all the possible information tools. And in some cases, you may provide a model choice tool. One, I forgot, 2 years ago, we have one day, I-270, the one I show you, completely shut down by a major accident. So we have an emergency operation, provide a bus to commuters. I tell them don't get on the freeway. You have a free bus today. The metro running the bus have a special bus team to pick up everybody. So that day, always start working hours start from 10 a.m. instead of 9 a.m. So you have to do a lot of emergency response for major incident or accident. One way I like to inform you that when you are doing a PowerPoint, I always want to see a nice picture, okay? I don't like to see the black and white. So my student give me a black and white PowerPoint presentation. I always give them a hard time, okay? Life need to have a colorful life rather than a black and white life, okay? So you see all my PowerPoint usually have a nice colors because all students has been trained by me to create a nice colorful PowerPoint or videos. So keep in mind, if someday your bad luck have to make a presentation in front of me, don't give me a black and white, okay? I should learn to use a colorful information, colorful presentation too. Then you have a create a coordinate plan. Of course, that will not be your job. Okay, if you are running a private travel club, you can say private travel club with iPhone, management plan is not your job, but you can access management plan, provide to your travelers, your customer. For example, you tell them now they have a ramp metering control. Okay, don't use which ramp. Or now they have a speed management. Or okay, tell them where they have a police now, try to get around the police detection. You can provide the service and information too. Management plans operate by the available strategy. You see a ramp metering case. You have a speed control. Here's speed control, ramp metering, detour operation, signal retiming, merging control, lane-based control. Okay, that's all the possible tools. Also, I think they already detour operation includes the route guidance. There's almost just all the possible control strategies you can use. Each one needs some models. Okay, again, you still don't just think about using information. Otherwise, students in the information technology, they can do all the work and take over your job. That's not the case. So IT system, in my lab, I still have 3 programmers work for my student. Not students are lazy. Even though they know how to do programming, they still want someone to do for them. Okay, but still we need a traffic engineer. Still, I need my student. I cannot just rely on traffic programmers, because computer science student or information science student, they don't have idea of those traffic problems, traffic natures. So your job will not be taken over by the computer science students, because you have those ideas, you have those model strategy to use. Okay. And create a management plan. For example, use a ramp metering detour operation. Then you need to know when to activate your ramp metering, when to deactivate ramp metering. If you don't no need for ramp metering, don't do it. Okay. When to start the detour operation. The problem is you make detour too late. It's not going to affect. Detour too early, or the incident will be over by next 5 minutes, and you still do a detour operation. You mislead so many drivers to detour to other route. Actually, take longer. The next time nobody can follow you. Okay, so when to do activate all those control and deactivate all the control are the very important information. Okay, it's a research. You think about it, Route 1, freeway number 1, want to do a metering control. When they should do a metering control, when they should terminate. Those is not a judgment issue. And if you do a detour operation, you have to change the signal timing. You don't retime the signals. How can you do a detour operation? I follow your idea to detour. I'll give an example. One day I was in the northeast coast on the one highway I forgot. I found out I was trapped on the long turner. I said, why? Trapped almost 20 minutes. By the time I get to intersection, I still queue. So my friend drive a car. I get out of the car. I went to check the intersection. Indeed, as I suspect. You know why? Because that route on the turner, during the weekdays, no traffic. So they give a single timing for what? Very small traffic number, single timing. But during the weekend, had huge traffic volume. It says in location, northeast. But the signal timing still maintain what? Maintain the weekday signal timing. So when I went to check, the cross street actually no traffic. All drivers still very nice, no traffic, but everybody still follow the signals. That's the reason you do not change the signal timing for the demand. Then how can you expect people to follow you? Same as the detour operation. The worst case, detour operation, they ask you to detour, take the alternate route. But they do not change the signal timing. Or they forgot, or they don't have the access. Because if you have a pre-timed system, they don't have access to change the signal timing. Then what happens? The volume after detour could be 2 times the original traffic volume. And then you create a long queue on the arterial. then you may think about, I will be better off if I stay on the freeway. That is a problem nowadays. Our freeway traffic bureau cannot implement detour operation or during the new holiday or congestion holiday, because in most cases, detour will get worse. Why? Because local signals are not operated by the freeway traffic bureau, and most of the pre-time. They have nowhere to change. So you get on the service street, it's worse, okay? You may just stay on the highways, stay on the freeway, listen to your radio, or watch your iPhone, could be more useful. That actually happened. No? Unless freeway have access to the detour route signal condition, the detour operation cannot be successful unless freeway is what? Complete blockage for 2 hours. Then you know, hopeless, okay? So that time the traffic control strategy cannot be effective. It's not because the method is not good. It's your what? It's your supporting element, supporting devices, supporting plan cannot work together. Okay, then you can do your operations. For major event, you can have multiple plan and do your simulation and comparison to select the one for actual implementation. Again, for detour route, with cell phone system user should be able to take advantage to receive more detailed guidance, because a lot of time detour route without the information is they only put the turning sign detour information at major intersection, but they do not put enough direction sign. Drivers very common get lost. Okay, blind lead the blind. If 1 or 2 drivers go to the wrong direction, all other people will follow them. Okay, that's very common in those conditions. So again, with the mobile sensors club, you can have up-to-date information for your guidance and detour operation. Successful or not, the detour operation really depends on your information. Okay, that's why the traffic bureau usually don't do the detour operation unless necessary, because a successful operations need a lot of supporting devices and supporting staff. And do some comparison plan to see what is the better one. For example, detour and not detour, okay? What would be differences? Create a new plan. Again, that's not your job, that's control center job. You can just keep track of the actual operation plan. You see always, detour always followed by what? Signal retiming, okay? If no signal retiming, don't do a detour operation. You are trapping people to those local bottleneck. Because local detour route usually do not have enough capacity, okay? And compare 2 strategies to see which one come with better result. Hopefully, those research can give you some idea. You may not need to know the entire operation to do all the job, but you can always find some area you can fit in to do your own research or play your own role to the potential applications. Okay, so you identify where are the signals. If the freeway bureau cannot change the signal, they at least they can coordinate with the local traffic bureau to let them know, hey, please, those 5 intersections, we need to change signal. Send your police, send your people go there to change the signals to facilitate the detour traffic flows. But again, you got to know where are those intersections, where are those signals. Those must be in the impact area on your detour route. Okay, let's get over with this plan. To return those signals, hi, too many plans. My student create too many plans. Okay. Plan 3 is to have all route metering, detour, and signal time together. Okay. So you can compare individual plan and integrate plans to see how much benefit, whether you need to do all together or just one should be enough. Okay, this one's more with all the freeway on-ramp control. You can see those on the interchange area. Okay. If you're going to do route metering control, it's to limit the access of the driver. So don't let them continue to come to the congested area. Oh. Okay, select a detour plan based on the freeway access control. Here's action location. Here's detour plan. Okay. This is not easy to know. Okay, because you can detour people longer, detour people this way. So this is research. If you want the optimal one, if you don't have an optimal one, you can have a pre-identified. In our case, we identify every, we call the FIDM plan, freeway incident management route. We identify every segment. If this segment has a major accident, what would be the potential detour route? Predetermine those pre-detour route. Because in real time, we may not have information. So we use the predetermined route to do a detour operation. Of course, ideally, you can have a model to compute for you, okay? But again, most of the state, the actual operation is they simulate those scenarios. Every segment, they already have one or two major detour route to work together. They ensure the detour route have what? Minimum number of signals. The detour route should have a sufficient lane. Each direction should have more than one lanes. Minimum number of detour route, minimum number of signals. Otherwise, drivers prefer not to take a detour route with many signals. And of course, there's no speed camera, okay? And you have to retime signal at the intersections. Inform the local driver. But in Washington, D.C. and Virginia now, those detour routes have two. One, for minor detour route. Those detour routes is major arterial, mostly operated by freeway bureau too. If you need to take a much longer detour route because for the major accident, then for example, this route is not operated by a freeway bureau. Then will be more problem. But in the Washington, D.C., because I mentioned earlier, the problem between the freeway bureau and local traffic agency. So highway agency now in the Washington, D.C. area, they operate those detour route signal and all the maintenance. So so main freeway and detour route constitute what? Called commuting corridors. So they work together. In this type of operations can be more efficient, okay? So they minimize the communication problem. Those signals are operated by the Freeway Traffic Bureau in Washington, D.C. area, I believe in Florida too, and Texas. Otherwise, can you think about just by calling the local traffic bureau, say, I need to change the signal timing for this intersection, will take another half hour, maybe 1 hour, okay? And they send the technician go there to change or go to the control center to change. The communication will take much longer then bearable to the drivers. Those all called ITS project, okay? I tell you, ITS project in a way is just use multi-sources of information on available technology to do whatever you can do. And ideally, this is more ideally, okay? Given those candidate route and plan and signals, then you have a signal optimization model to come out a better plan. But in reality, you may not have an optimization model. But at least you can approximately increase the signal timing for the detour traffic directions. But from the research point of view, we should have what? Responsive signal timing plan to optimize signals, okay? You can always play with the games. And update your data. And see the result. See which one is better and actually implement, okay? Although it will take a long time to describe the process, but in actual operation it should be what? Smoothly, seamlessly implemented, rather than keep thinking about it and take another half hour to get done. Those processes should be automated, okay? Step by step automated. And you see your plan and select the most promising one to do your actual implementation. Okay, see the plan 1 result and plan 2 result. Again, if you show those to the current traffic center operator, they will tell you, oh, cannot be done, oh, too much trouble, okay, by nature. But you think about, is this involve any advanced technology? Not. That's all common computer programming, GIS database, that's all. You want to optimize, maybe require you to have more mathematical model. But even without optimized program, the system can still function. Optimized may be better, but that can be improved slowly, one by one. But as long as you integrate all information properly together, that will be useful information, okay? So the idea I want to present to you is how to integrate available information together, become efficient applications. And then next step, you can have an optimized model for your research, okay? Here's a control plan after you retool, redesign, evaluate how good your plan. You can see a different plan with the ramp control. Okay, here's the ramp. You can see where the ramp control meter rate, okay? Based on your optimized or experience-based control strategy. Okay, then all get done. You can see which one's better and to implement. There's location information. Okay, what actual traffic condition and percentage of volume at the detour route. Okay, how many percent the detour route and what is speed information. Based on your proposed detour plan, of course, you can rank those plans and to see which one, because the best one may need what? May need much more manpowers, okay? So best one, from traffic benefit point of view, may be the best one, but you have to consider whether your operation center have enough manpower or not. I told you, detour operation, you need the law enforcement people at every major intersection, major turning point. Otherwise, detour operation may not be successful. So you also concurrently have to evaluate your manpower available or not to select the plan which can reliably, effectively implement. Ranking the plan and then do the cost-benefit analysis. Suppose all the criteria, then you choose one. Finally, again, those processes can be automated, okay? Can automatic process for ranking and selection of a variable management plan. You don't need to step by step. Okay, we'll be done soon. Okay, based on the cost benefit and the reliability of the system, we have a student working on the, my student Woon Kim just published a paper in the past 2 years, continuously working on this area, just ranking and selection of all the different possible plans in the real-time operations. Okay, consider the reliability, safety, all those issues depend on your criteria, and resource availability too. Here's what benefit cost ratio. Okay, safety, reliability, acceptability. Acceptability means how quick you can access the detour route. Acceptable or not based on information. For example, how many intersections and what is the speed limit. You ask me to do a detour route, appear to be very close, but the detour route, the speed limit may be very low, right? 25 miles per hour. I don't want. I may be more willing to go to the longer detour route, but with high speed. That's called one of the acceptability. Okay, accessibility depends on whether that area entry exit to the freeway. Safety, reliability. There's many factors related to a geometric condition too. Okay, so consider all those factors, and you combine together to rank the system. But again, this part is more like what? Research, academic work, okay? And the Freeway Highway Bureau, they don't do those all the evaluation unless for a major special event such as the New Year, for example, New Year's traffic movement plan. That is, you can do much longer advance time for your planning. Then you can do all the analysis. Okay, if for the accident scenario, usually take one feasible implement. Here's referred to a major operation. Otherwise, they don't go through all the comparison. But in the mainland China, the October 1st, long holiday, yeah, you need to do those kind of operations. That involve huge volume and much longer time, okay? And they implement. Okay, choose, after you select information, you feed back to your potential users or in-route traffic operator. Let them know, okay, here we're going to implement the plan. What would be impact on you? Please cooperate. So with them, without cooperation from the drivers, make huge differences, okay? If drivers do not cooperate with you, they don't get your message, then you will continue to have a longer time of congestions. This shows you congestion conditions. Sending a plan from the verbal message on the broadcast. I mention again, you have to design a system. Active system means if your cars already into the traffic impact area, I should be able to actively send you the message, let you know the accident. Don't wait for driver to call. Many drivers has no habit to call the control center or listen to radio about traffic conditions. They only call when they see the traffic. They only call when they are caught trapped in the freeway congested bottleneck area. So if they call that time, means what? They already contributed to a congestion. They already contributed to a queue, okay? So what we want to do is actively send a message to them. If your car's within my impact zone, you will be forced to receive information, tell you the traffic condition, and even to tell you advices. Those kind of design is very important for what? Particularly for emergency evacuation. Let's say nuclear power plant have some emergency. You may not report to you may not broadcast to everybody, but anyone close to the area will be actively receive the information to go away, to do the detour actions and follow the instructions. Same as the idea here, okay? Broadcast. Broadcast has a problem. If they don't turn on the radio, it may not be able to broadcast. Also, broadcast the information is not easy to be complete. Usually, broadcast information has to be short. Same as VMS messaging. How many sentences you can put on the VMS sign? Usually short, okay? So still, cell phone is a one we should take advantage, okay? Okay, I want to stop soon. Incident warning, okay? If you try to, when you research issue here, if you try to use information to affect driver's behavior, you concurrently have to study where I should send information, what kind of message I should send to driver. Remember, your message, your language will affect driver's response to you, okay? If tell them incident advance, incident ahead, be alert, they're not going to do anything. If say incident advance, incident ahead of 100 feet, speed is how low? Or they may have a different way to respond to information. If tell them incident ahead, you will be ticketed, you continue proceed. They're going to change their route, okay? So depending on what message you provide to them, it can affect their response. That's very important. Drivers, most time, they don't trust traffic bureau information, I tell you, okay? Think about yourself. They have so many times the message is useless. Driving carefully, be alert. It's not useful unless they tell you police is ahead of you, okay? That would be useful. So that's another area of research. How to use information very far away from the impact area. You want them to take a different route. What kind of message should you provide? They're close to the incident location. The message should be stronger with some kind of language. But you only have so many words you can write in the VMS sign. You only have so many seconds information to broadcast. What message should tell them to be able to force drivers to work with you? That is very important research in the behavior and human factor area. Now with iPhone, it should have more study. How do I send a message to iPhone to alert you, okay? You may send them a red color explosion like a bomb, bloody information, and they may be scared and they change your route to follow you, okay? And you send a very soft, friendly message. Can you please follow advice? Well, they say, sorry, I'm not going to follow, okay? So it's a very important research. You can publish a lot of paper by doing those kind of study the information, okay? I'm not kidding, that's actually happened, research, you know. At least 2 journals working on those research area. See, you have to define the broadcast area and what kind of information to broadcast, okay? So transportation, especially for control operation, need the expertise from all different areas and work together to create a livable, friendly, nice commuting environment, okay? Not just by 1 or 2 engineering expertise can overcome those potential and ongoing a lot of issues. Instant warning, okay, how long it should broadcast. Remember, a lot of times you can see the incident is already over, the message is still there. That's not uncommon, okay? The detour is over, they still show you the detour information. That's nowadays okay, but 20 years ago, even in the United States, still very, very commonly happen. Detour operation, you don't follow them, okay? You see traffic is already light. Well, they forgot to turn off, okay? And they try to be conservative. Okay, so those are all could happen without the real-time information and proper control and feedback. Should be down here. Okay, ramp closure, you better let people know. You close the ramp, you don't let them know in advance. They get to there, find out the ramp closed, and then you'll be in trouble. In the United States, they'll call you, curse you, okay, and complain to your boss. The ramp closure information you have to show to the driver and far ahead of. That's why we define the impact area. Usually broadcast or display the message within the control area, and immediate access point to the control area should also be included, okay? Detour advisory, that's a most difficult job. If you can do a good job, you can apply in the Chinese New Year, those long, the first day or second days, the huge traffic from north to south. Okay. The Freeway Bureau does not want to do it because they don't know how to provide advice. They only show in the newspaper, ask people to follow. But the data shows very few people follow the detour advisory because they will get lost if they take a detour route. And also they ask you to do a detour selection. They don't provide any assistance. As mentioned earlier, detour route could be a poor route without signal control, without the messaging, unless you are very familiar with the area. Otherwise, very easy to get lost. You get lost, maybe okay, but it may mislead to follow you to get lost during that congested peak demand period and create a huge problem in the targeted detour area. So a lot of times during the failure in the detour operation, you will see what? Quite a lot of traffic wandering, driving around in the small town area do not figure out where to go, okay? And create a huge problem to local traffic too. So how to do a detour operation and advisory? It is a tough information management issue. In this area, at least can have a 3 or 4 PhD student work and 5 to 6 master student work, okay? If you like to work around. You can also do the system without any PhD work or master work. If you all based on experience, okay? Still can construct a system. Okay, signal time. After you detour, you need to remember to signal reautomation. Okay, so you can see these are all within the control boundary area. Okay, all the conditions after your plan. Okay, and display all the information. Display the adjusted route and compare with the current travel conditions. Define new detour route after your comparison. This is a new detour route, okay? On the new detour route. So, concluding here, you need to keep monitoring traffic after plans change. Remember, traffic is dynamic, moving, okay? Not static. So don't say my job is done after I complete all the control operation. Sorry, you have to keep moving because drivers don't all follow you. Okay, drivers could change their mind and change their route. So condition continue to change. Your systems continue to operate until what? Until the incident is over. Okay. So the challenging part of traffic problem is you always interact with the drivers, with the motorists. It's a dynamic stochastic system, unlike EE's electrical system. So it used to be, even now, a lot of EE professors or researchers, they always think, yeah, that's easy. Traffic network will be similar to what? electrical network, right? They work on the power electric area. Traffic should be similar to water pipeline research. They can use all their application to transportation. Sorry, once they work on, even EE people that work on, they found out it's not true. Water will listen to you, okay? Electrical current will follow your suggestion too, but driver don't follow you, okay? Unless you have ID track, iPhone track. You have a big brother to watch them, force them to follow you. You cannot control them. That's the trouble and difficulty of the traffic system. And that is also the fun, the interesting of the traffic research. They don't follow you. You don't want everybody to follow you either, I tell you. Everybody follows you, then there's no fun and no uncertainty either. Everyone will be just a particle, right? Not the actual dynamic system, okay? Okay, we'll stop here. Report it. Okay, one important thing is, okay, secondary incident. That's, you need to have this knowledge, okay? Every major incident create a secondary incident. Secondary incident means the duration is shorter but minor, because driver get impatient, driver try to change lane, driver try to escape from the work zone, driver try to do a detour operation, cause minor incident. If you look at database, there's 2 accidents very close together at same location geographically as very close time interval. You can classify as a secondary incident. Let's not stop here. It should be stop here. Okay. The secondary incident, that is one of the issues. Also claim your benefit. If you can quickly remove the major incident, then you have a probability to minimize the potential secondary incident. That has the report and the research available in the literature. Okay, we'll stop in the step 45, okay? 2 more. Why is it so slow? Need a fast computer. Okay, basically, the worst case is you have major accident and several minor incident, and all together will be a regional accident. Then you should advise everybody to take 1 day off, not to come to office. So actually, the same procedure, just to report a secondary incident. Okay, secondary incident usually does not require what? Ambulance. That's the difference. Okay, do not require to have a fire trucks. Okay, one more. Stop here. How many more I have here? Huh? Didn't know. Okay, we stop. Next one. I need a break. The same as a primary incident, okay? Just report the issues involve only property damage, no injury or no fatality. That's the nature of the secondary incident. Okay, we stop here. See you tomorrow.